All right. Then the other thing, which we've done before, and we're going to revisit it now, is interpolation. And so this is the equation that we showed you back when we did this exercise, where I had you look it up in Wikipedia. When you have known points, okay, let's say we're calibrating a transducer. So we measure its response at two known values. So let's say it's a pressure transducer. We measure the output voltage at two known values of pressure. And then we want to be able to interpolate between them. Right? So if we get a voltage of 1.5 volts, what pressure does that correspond to? Well, we can do that by interpolation. And again, the simplest kind of interpolation is just you assume a straight line, which means you just take those two known points, put it into this equation, put them into this equation, along with x, which is the value at which you're trying to do the estimate. So in this example, x1 and x2 would be the two known voltages, 1.0 and 1.7. Y1 and Y2 would be the two known pressure values, 20 and 30. And then X would be the value that we measured this time, and we want to know what pressure does it correspond to, and we're saying to use 1.4 volts for that. All right, so first, here we're actually just doing it for you explicitly. Okay, so if you had to write your own interpolation function like we made you do in the exercise, although a fair number of you didn't do it, this is how you would do that. Okay, and it turns out to come out to 25.7 psi. But you can also use the built-in function interp1 to do it for you, where all you have to give it is the set of x values, the set of y values, and the x value where you're trying to do the estimate, and it will give you that interpolated value. Okay. Now for the exercise, and again, it's the same problem that's shown here. Now let's say we do a bunch of measurements. And see, does it even say what this data is? I mean, it's all made up data. It doesn't really matter what it is, but just some data. I guess we can consider it to be the just an extension of this sensor calibration problem. But let's say we do a bunch of measurements. When we have this set of inputs, we get this set of outputs. And then we want to interpolate all between those values, not just at one or 2 points, but we want to do a continuous curve. So like generating a calibration curve based on a finite number of data points. What we can do, we can actually set up a vector of uniformly spaced x values. I'm calling it x interp. And then you use interp1 to calculate the interpolated values for all these x values. Right, so you're going to take interp1, but instead of what we have here, the first argument is going to be this set of x values. Okay. The second argument is going to be y mesh. And the third argument is going to be this vector of x values. Okay, so it can interpolate multiple points at once. And it will give you back a vector of the interpolated y values, which you can then plot, and you'll then see this piecewise linear curve going through the data points. Now, just so you're aware of it, you can also do other types of interpolation. It doesn't have to be linear. Actually, I'm going to see, can I run this as it is? Let's see. All right. So I got an error here, but that's okay. That should be all right. You can do not just linear interpolation, you can do what's called cubic spline interpolation, where instead of just doing straight lines, it fits a smooth curve. It's a third order polynomial. It's not a curve fit. It's an interpolation. Basically what it does, it takes every 4 points and fits a cubic curve to those 4 points. Then it goes to the next one and it does a cubic curve, for those 4 points. So you end up getting a smooth curve that goes through all the data points. Okay, that's the difference between curve fitting and interpolation. When you interpolate, you get something that goes through all the data points. With a curve fit, you get a smooth curve that follows a given functional form that passes close to all of the data points, okay? With the possible exception of some outlying points. All right, so that's the difference. Interpolation goes through all the data points. A curve fit does not. All right, but in the exercise, we'll just have you complete this problem. Just do linear interpolation to fill in between the known data points.